Hi everyone, my name is Thiago Lobo. I'm from São Paulo School of Economics. And so let me just take here in the LSE and the organizers for today for allowing me to present my work here. I'm from São Paulo School of Economics at PGD. And I'm going to present you today technological progress and climate change, and this from the agricultural sector. This is co-authored by Daniel da Mata and Mario Dota, my colleague. So the whole point here is that every time you have a leap in technology, it's associated with some kind of environmental damage, okay? And we have like historical cases like the Industrial Revolution, but by now, we know by this that greenhouse gas emissions are the primary cause of climate change. And said that in the agriculture, there's a lot of heterogeneity in terms of emissions. You can think of like, that's the next slide. I'm sorry. But the contract sector actually can have two roles here, so a two paper. So I'd like to say, can be a victim because when you have extreme weather conditions, it's going to have less land to crop and to produce food. There's also a culprit because it's responsible for 1/3 of the GHG emission globally when you account for logistics. And food demand will only place further pressure in this. But if within the agricultural sector, there's also a lot of heterogeneity in terms of emission. If you take like one global warming potential come from the carbon dioxide, and you take like methane, comes from the enteric fermentation. So like when cows are digesting the grass, so to say, and you can have like 20 times the limit of the impact. Okay. So when you are producing like bovine meat, 100 grams, so you have like 100 global warming potential. So when you're producing like soybean oil, it's like only 6%. So it depends on the set. What are you looking in the agricultural sector can vary a lot in terms of emissions. So when you have innovation in the agricultural sector, there's one point here that's important to understand is that it can reduce the pressure in the environment because you can have like an innovation that is land sparing. So, or like augmenting in the sense that you can produce more with less land, and that will help to keep the forest up. And also at the same time, so this is called the Burlock hypothesis, but you can now have an increase in terms of pressure in the environment because people would like more land to produce, and that can lead to more land clearing and deforestation and so on. And GHG can go either way, okay? And the point here is that Brazil is a suitable framework in the sense that we are a major player in the agricultural sector, and we do emit a lot of GHG, but it's not coming from energy at all. It's coming out nowadays coming from the agricultural sector that we have already surpassed the land use deforestation. People don't usually know that because that's only the evidence. But in Brazil, there's a point here. This whole thing of being a major player has come with the genetic modified organism. So we need to understand that in order to understand what is happening in Brazil. In particular, the GE soybean, the genetic engineered soybean, that changed Brazil a lot. Just to have an idea. So this is soy, like a very nice bean. It's like this high, the plant's like this high, and it was released by Monsanto in 1996. Basically, the technology that's resistant to glyphosate. So when you throw glyphosate in the land, everything that's planted is going to die, except the genetic engineered soybean. Okay. And the point is that the soil does not compete for soil nutrients; it can grow more. So, and also. It also has some like a side effect in the sense that it's more profitable to harvest seeds. So it's also more profitable to do a complementary crop like maize, because in Brazil you can harvest soy in March and then in September you can harvest maize. So double cropping in 1 year makes more profitable in the sense. So soybean area in Brazil exploded, and virtually all the soybean seeds are now GE soy, okay, from Monsanto. And this is how Brazilian landscape changed from 1998 to 2017. So you see a lot of major areas in Brazil here that are planting soy. Just to have an idea, this area here is like the tropical rainforest, but the legal Amazon comes like around here when you include the savanna areas and so forth. So the same idea is that when this kind of technology can also promote land clearing and deforestation, but it can also spare land, depending on which point of view, and I'm going to show which one is going to prevail in this case. So what we are asking here, we are asking basically if technology advances can mitigate GHG emission by offsetting somehow, which is what is the mechanism behind all of this. And the idea, we are going to use a quasi-experiment from Brazil, and we're going to use dynamic differences. So we're going to show that the productivity enhancing can promote decoupling from emission. Okay. Also, there's a decarbonizing response in the sense that they are changing from a higher emission sector to another within the agriculture, and another perspective for Burlog and Jevons paradox. Okay. So there's a huge literature on that. So just going to pinpoint some things here. The sense that a lot of people see there's a trade-off between economic growth and the environment. What we are seeing here is that depends. So maybe that's not always the case in terms of technology. Also, there's a lot of thought outside of the economic literature. You can say a lot about clean, like electric cars. They're going to actually substitute or replace GHG emissions. But what we're seeing here is that technology that has nothing to do with emission, but it's causing a decarbonizing effect in Brazil. That's what I think is interesting here. And what I'm going to just say here, we use the measure from Bustos, 2006. We were born in that measure, but she explores it in a first differences, and we're going to make that differences here. And another point here is that we are looking at a global externality. Okay, so a lot of people are looking at how the glyphosate, so the herbicide, is affecting human health. I'm also looking how the genetic engineering soybean affected the local externality in another paper, like violence, for instance. But so just having an idea, a lot of people are looking at this. But what happens? To understand our empirical strategy, we need to understand the mass they did in Brazil.
Just following on the point of this global economy, is it possible that what happened in Brazil happened affect other markets? So, for example, it might be that emission goes up, but emission somewhere else goes down. It's kind of, do you have anything about that? If the share of soybean production is going up over time in Brazil, given what you showed us before?
Yeah, in Brazil, the soybean, I'm going to show that.
Okay,
so the GHG emissions in Brazil went up. But also, I think your question is important because maybe we are producing soy here to sell for another country that is using that. So I'm going to look exclusively in Brazil, but that's something that we are.
That's the challenge with looking at the global economy.
Yeah, that's a big problem. So what I think it's like a partial equilibrium. So in this sense. Okay, so in order to understand our empirical strategy, we must understand the mess that the judiciary did in Brazil, because in 1998, our Biosafety Commission approved the use, but shortly after, the judiciary banned it. Nobody could harvest, and then again, they extended the ban in 2000 to any commercial purpose, and 2 years after, a reviewer instanced just leave the ban. There were some grounds, seeing that there was no legal ground for that. It took some while. So we're going to say in this sense that the exposure to the technology, the soybean started in 2002, and nobody was expecting that in 2001. This is going to be our omitted year. In Brazil, not everything is linear. So the south of Brazil were like using soy seeds, but our results are robust if you include or take them out. Okay. What is this measure? So this is we borrow from Bustos. It's basically a theoretical measure that comes from Food Organization. Okay, so this is Falgaez. I don't know if you know about it, but it's measured in tons of per hectare. It is dry weight, doesn't contain any kind of water inside. So the idea is that this measure, this theoretical measure, so considers three inputs: technology, geoclimate, and water supply. And we are doing like systematic control here. We're controlling for everything that we can: physical capital, fertilizers, allowing only to remain the good variation here. Okay, so only what you need. So the GMO seed in the case of the soy seed. And gel climate, we're also controlling for that. And water supply, this model allows us to take only the year before the treatment starts, okay? Before, so 1996 to 1999. Importantly, what this does not consider is the soil suitability, okay? So, and also land slope, that's important in agricultural sector, okay? Both these are outside the model, so you have to worry about that. So as in boosters here, you're going to use these differences where A high is the productivity level using all the current technology available, okay, state of art production. And A low is the rudimentary farming process, okay? You would like throw some seeds and it grows great, doesn't okay. So in this case, we normalize this manager to mean 0, 1 standard deviation, but keep in mind that's just half a ton per hectare of soil, okay? Just have an idea. So this is the potential with differences. So I'm saying that on average in Brazil, we had like 3 tons of soybean increase, potential increase. Most of it's over here in central Brazil. So it's a lot of soil, a lot of money you can pick up. And this is the distribution, productivity distribution among the municipalities in 1998. And this is the potential from Algaes. And here's where we are in 2017, okay? So it's like it's pushing toward the potential. So it's really happening there in Brazil. So it's a common dynamic differences and difference framework. Everybody's treated after 2001. Once treated, never go back. So the idea is that I'm using the difference, the A here. I'm controlling for municipality and time fixed effects, time varying, geoclimatic variables, rainfall and temperature. Pre-period, socioeconomic, agricultural, everything that's available in Brazil, live data, good data. Okay, so I'd like to say here, the identifying assumption that without the G soybean, in terms of emissions, the trend will be the same. And we explored the fact that the G soybean was developed primarily for the US market. And there's a clear timeline, the method I told you, the geodesic system allows us to pinpoint the year exactly. So, and it was basically orthogonal to emission by then, but now because the oil meant like to build a G that could be more efficient or use better carbon to develop. That was not the case. So localities with low exposure are a counterfactual for those that are high exposure to the potential. Okay. Confounders also a little bit so pre-existing differences, confounders, boost all of this. And just pinpoint some data that we use. So Algaes, as I mentioned, the grid cell. Brazil has a lot of data in the agricultural sector, like yearly annual surveys at the municipality level. But the most important here is the data that's coming from SEG. So Sistema Estimativo das Emissões e Remoções de Gases de Efeito Estufa. So this SEG here, the GG emission here starts in 2000, so I'll give us only one period for analysis, but I can see exactly if this is coming from soil emission or cattle breeding or, I don't know, maize or the whole agricultural sector. So it's pretty rich data at the municipality level. And also we are using the emissions database for our global atmospheric from Edgar, but it's not crop specific. So we're using these two data just to show that they are going in the same directions. Keep in mind that complementary crops are those crops that can be harvested in the same land year, okay, like maize and soy. Double cropping is effectively doing that, and our carbon intensity is total emission divided by agricultural outputs for 1998. So all the results are robust. So the results are the same if you look at tons, heads, or productivity, but I'm only showing here in terms of area. Okay. So what happens here? 2001, so no pre-trend. 2002, we have the first year of the treatment, exposure. You have already, on average, 1,800 hectares of soybean area. So one standard deviation of potential yield, soil yield, increases roughly like 200 hectares of soybean area. This is like 10% only in the first year. This effect accumulates over a year. It's all like 1 month, an increase of 100% almost. And the G, so what is important here to say is that soybean is an economic activity that is going to emit GHG as any other, okay? So it increases almost like mechanically, and we know where it's come from, where it is coming from. It's actually coming from the residual. So after harvesting, the organic matter that is left on land is going to decompose, and this leads to increase in the emission. Not much from leaching. They have the same axis here, so to have an idea. And what is interesting now is that complementary crops. So the idea here is that complementary crops did not take off in the same pace as with the GE soy. Our interpretation here is that it takes some time for the farmers to understand that it's really profitable to plant both. So like maize and soy, that's what we do a lot in Brazil. But when they get when they learn that and they know that they can use this double cropping, complementary crops starts to grow and does not end. And the point here is that the pasture land, so the municipalities that were more prone to this technology, were over time reducing the area dedicated to pasture. Okay, so they are farming away from a sector that is more, needs more relative to the soil, And so also in this sense, what I'm saying here that the complementary crops is that also emits GHG. And at the beginning, how we see our results here is that there's like a income effect. They have more money, but they're used to raise cattle, so they're going to buy more heads. But in the long run, they're going just to farm away from the pasture. Okay, and does that lead to any competing mechanism? Sorry,
I think we're talking. I mean, I thought the productivity buttons on some of your graphs. So,
okay.
is there per hectare, or does the emission go down?
Per hectare the emissions. So our carbon footprint is going to consider the emissions. Sorry, you think productivity or emissions?
Sorry, what I was just wondering is the technology makes it more per hectare given space of land, the emission.
Yeah, it makes more, but so we are using our main measure here is the carbon footprint divided by the output, not by the productivity. Okay.
Sorry. When we have all these emissions that you said come from like leftover product, are these clean out of sequestration when the plant is growing? So are we expecting this to be net emissions or
gross emissions? So we're not capturing like the carbon cycle or sequestration. No, this is just total emission.
So it is possible that relative to the past crops, this might be sequestering more carbon and we actually have negative, or that there's actually no difference, or just anything with these new soybean changing technology that makes it produce more emissions than whatever was before, or the country factor. Can you talk a bit about that?
Let me see if I understood your question. So first part of the sequestration. So I don't know if I can say anything about that, because there's a cycle between like growing, the plant is growing and taking out, and then what it gives afterwards. So I don't. We're going to always look at total emissions, but because this is important. Actually, this is very important when you consider the carbon cycle for pasture and cattle breeding. There's it's very. People are discussing if the cattle breeding does really has that impact because of methane. Because for instance, methane has like a shorter life in terms of global warming. So, but here, I don't think I can go in that direction. I don't go in that direction, but maybe it's a good point to explore in the future. Okay. So, okay. Competing mechanism. So did that lead to deforestation? Actually, it didn't. So as we show here, there's no evidence of deforestation. So the natural forest area remained for those areas that are more prone to the technology, more exposed to technology. And also they did not clean the areas using, for instance, fire, there's no clear evidence about that. And what happens here is that the total area dedicated to agriculture, it's actually the same over time, okay? In the sense that, so what we capture here is that there is a large increase in the production, okay, without actually having an increase in the total area, because they're farming away from the pasture area. And what we have here is total emissions remains relatively stable over time. And when we take here our carbon intensity, we did actually do a first measure using the intensity by dividing by the productivity level, but there's a lot of noise within that measure. So we decided to go this way. And we have some evidence here that is decarbonizing, in the sense that there's a smaller footprint, carbon footprint. And last, we do a comparison here. When we compare, for instance, Amazonia Legal, that large part of Brazil that I was mentioning, tropical rainforest plus savanna. And what you're seeing here, that's more potential in those areas in the biome of Amazonia is not related to more area dedicated to soybean, okay? So also the carbon intensity does not change in this way. So where it's coming from? It's actually coming from the other areas, so the remaining of Brazil, the central part and south one, okay? And our results are robust to this, so we get in the same way if we use or not controls, if we put all municipalities because of the soft contamination that I mentioned, spatial threats like larger unit analysis, price, so we know that the agricultural sector is very sensitive to prices, and commodity booms also, we did some control, some robustness tests, extreme values at 1 and 2% of the treatment variable. Another alternative specifications, such as like residual regression, same results, and the giga versus Falgaes is like the Falgaes is bottom down and top down measure, and there's a giga that is bottom up. So it sees soil quality and computes the potential depending on the local weather, local soil, but in both ways the results are the same, okay? And that's here to say that, so we are assessing how technology affects greenhouse gas emissions. It's important because it's like 1/3 of global emissions. So in Brazil, that's really quite important because in the last 20 years, the agricultural sector was the only one that had any economic growth. So like the other sectors are like really stopping all the time, but here we are more productive, we're growing a lot in the sector. And so a back of the envelope calculation here would say that without the soybean, to achieve this amount of production we have today in Brazil, we will require more, 30% of emissions. So it seemed quite okay, quite reasonable. But at the same time, we didn't access the idea of the carbon cycle because there's some, so people say that there's some sequestration coming from harvesting, people say they don't. Some say that pasture, so cattle breeding has a large footprint, carbon footprint, so others are saying that there isn't. In the way that here we're always looking at total emissions. So the point here is that there's also to see the future research. We think it's important to see the biodiversity and natural resources. I did take a look in the water, and there was not like really impact here. And so please.
Yeah, potentially just a clarification question, but I didn't quite understand how you capture for the potential spatial dislocation of like bee farming. Like if your treatment effect that you showed us is kind of within the spatial units that you analyze, like it may well be that sure big farming was kind of substituted away and like more soy came in. It's just like the the deforestation frontier was just moved
Okay.
elsewhere outside of your unit of analysis. No?
Yeah, no, that's a good point here, because people can, yeah, we had a feedback from, that were saying that usually deforestation in Brazil at least starts with cattle. So they deforest, put some cattle there, then the cattle go away, and then comes other crops like from farm, maize, soy, etc. So we didn't look at this. I did some tests, but not in this paper. Yes, we think we're going to plan another paper, like to say, where did the pasture go? You know, we have some evidence that it's not going to. I can just here. So municipalities here. So maybe so. What we know here is that actually, for one municipality, we have seen tested that the pasture didn't go to the next neighbor, okay? It went far away, maybe to the north. So that's true. So, but we are just thinking how we're going to put it, not in this paper, maybe in another one. But that's a good question.
I actually have a very similar question, but just to follow up, we also see increase in like import for those meat products as well, where you say Brazil is moving away from pasture.
So like meat import?
Yes.
No, because if you see our results here, let me see. So the idea is that there's almost one, like, so there's a lot of cattle breeding in Brazil. I think there's almost 200 million heads there. So what happens actually is that the quantity of heads in Brazil did not decrease as fast as the pasture area. Okay, it was like a small decrease. So, but this small decrease is sufficient to compensate the emissions from the GE soil. This is the example that I gave here. So, like basically cattle breeding emits methane. So if you take only one head of cow, you can produce a lot of soy. So, but there wasn't this, because there's still a lot of production in Brazil going on.